In this video, we're going to solve what's called a cascaded op-amps problem. So cascaded op-amps are just when you have multiple op-amps that are connected into each other like we have here. In this case, we have 3 op-amps. And we're going to try to solve to find the value of V is 0. So this is our typical op-amp problem that you'd expect to see. Just start anywhere that you know values here. For example, this upper left op-amp, we know that based on the fact that it's hooked to ground, that the voltage on the positive terminal is 4 volts. But since it's an ideal op-amp, that means the voltage on the negative terminal is 4 volts. If we follow it around through the short, that means that the value of the output is also 4 volts. And in fact, that first op-amp is kind of not doing anything here. The output is the exact same as the input. This is actually called a buffering op-amp. There is something that actually happens with it, but in terms of the class at our level right now, it's really not doing anything with an ideal op-amp. If I look at the bottom op-amp here, I see the positive terminal is hooked up to ground. That means the negative terminal is also going to be 0 volts. And I'll go ahead and do node voltage at the negative terminal here. Let me go ahead and give a name to this. I'll call this V1. So then the current going left would be 0 minus 3 over 10 k ohms. And the current going up is 0 minus V1 over 50k. And the current going right is 0, because again, the current going into either of the input terminals on the op-amp is 0 for an ideal op-amp. So we can go ahead and clear out the denominator here, multiply by 50k. That would get me a minus 15 minus V1 is 0. So V1 is negative 15 volts. Then we can continue on here at the third op-amp. One side is hooked up to ground, that means that's 0 volts. Since that's going to the positive terminal, that means by ideal op-amp, the negative terminal is also 0 volts. And we're going to go ahead and do Kirchhoff's current law, or node voltage at this negative terminal here. So the current going left would be voltage I'm at 0 minus voltage I'm going to 4 over 20 kilo ohms. The current going down would be voltage I'm at 0 minus voltage I'm going at negative 15 over 30k. The current going to the right here would be 0, because again, ideal op-amp. And the current going up would be 0 minus V0 over 60k. Now this is an equation that only has one variable in it, so we'll be able to solve. Let's clear out the denominator, multiplying by 60k. 60k over 20k is 3, so minus 12. 60k over 30k is 2 times negative negative makes positive 30. And then minus V0 equals 0. And so moving things around, we're going to get V0 is 18 volts. So you see, it's generally not going to be tons of algebra on these, even though they look complicated with the cascaded op-amp problems here. But you just got to follow through using your ideal op-amp properties at each step, node voltage a bunch of times, and eventually you'll work your way over to the output voltage here, which we found to be 18 volts.